In a system, there are three processes P0, P1, P2 with the maximum need of resources are as. Resources are here. So P0, P1, P2 maximum need is 849 and the present they are working with 522 respectively, for example. If there are 11 instances of resource are, then the system is in. So there are total 11 instances. So in this case, so if you take 11 instances, out of 11, here 11 is there, total resources. Out of 11, 5 plus 2 plus 2, total 9 are allocated. Then what are remaining? If 9 are over, only 2 resources are remaining. What is the present need of P0? Need is nothing but maximum minus allocation. So the still need of P0 is 3 instances, still need of P1 is 2 instances, still need of P2 is 7 instances. So these available to neither sufficient for P0 nor sufficient for P2 because the still need is more than the available resources. So those are sufficient for P1 first. So first you have to execute P1. After P1 is executed, so we can release all the resources so that we can execute already current holding resources plus allocate resources, both will be released. So the now available will be 4 after P1 is executed. So those are sufficient for the process P0. So after P1 we have to execute P0. After 4 are released, then it will release 5, total 9 will be available. So those are sufficient for P2. So P1, P0, P2 must be the sequence in which the system is safe. So first you have to execute P1, next you have to execute P0, next you have to execute P2. So option A is the correct option here. Suppose when W is equal to 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7 be a page reference stream. So these are the list of pages that have referred in sequence. Given a page frame allocation of 3, so the number of frames allocated is 3, and assuming that the primary memory is initially unloaded, means initially empty, how many page faults will be given reference stream incur under LRU algorithm? LRU means least recently used. We have to go to replacing the page that has not been used from the long time period. So here we have to the solution will be like this. You have to consider 3 frames initially which are empty, So what is the first reference? 0. So 0 there is a fault, again 1 there is a fault, again 2 there is a fault, again 3 there is a fault. You have to replace 0, so it will become 3, 1, 2. 0 must be replaced here. Again after 3 there is a 0 again. So out of 3, 1, 2, 1 is the least recently used. So 3, 0, 2. 3, 0 and 2. So now here 0 is inserted, 1 is replaced. Again 1, 3, 0, 2, 2 should be the least recently used. So 3, 3, 0, 1. We have to replace 2. So again 2, out of 3, 0, 1, 3 is the least. 3 is the least recently used. You have to see the reference side, back side. So in order to insert 2, we have to replace 3. So it will be 2, 2, 0, 1. So after 2, it will be 3. Out of 2, 0, 1, 0 must be replaced. 2, 3, 1. Again 0, 1 must be replaced. 2, 3, 0. Again 2, there is no fault. For 0, what you have replaced? 1 you have replaced. 1 is the LRU. So again for 1, 2, 3, 0, 2 must be replaced. 1, 3, 0. For 2, 3 must be replaced. 1, 2, 0. For 3, 0 must be replaced. 1, 2, 3. For 4, 1 must be replaced. 4, 2, 3. For 5, 2 must be replaced. 4, 5, 3. For 6, 3 must be replaced. 4, 5, 6. Okay. So for 7, 4, 5, 3. 4, 5, 6. 4 must be replaced. 7, 5, 6. So the total number of page faults is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Option C is the correct option. Here we are going to replace a page that has not been used from the longest time period. So option C is the correct option here. Let the ready list contains 10 process which is to be scheduled using round robin scheduling. The time quantum is 20 time units and each context which requires 5 units of time. Then each of the 10 process will receive 20 units of time on the CPU for every dash units of real time. So we need to find out after how many units every process will get the time of CPU, after how many time units. Because there are 10 process in a round robin scheduling, how we do? Options given are 200, 225, 250 and 230. So there are 10 process. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 10 process. So what is the time quanta for every process? 20 milliseconds. So every process will execute 20 milliseconds. What is the switching time from one process to another process? 5 units. So here the total amount of time required for each process is not given. It is immaterial for us. Every process will get a time only after all the process have finished their time quantum. So every process will finish 20 units. Let us suppose that every process is containing the amount of time minimum 20 units. Okay, now so the switching time is 5 units. So this will be, so for the remaining 9 process, for example, you have to get 1 to 1 for example. For the remaining 9 process, 9 into 20 time units, 180. So how many times you have to switch to get over to the same process? 1 to 2 is one switch, 2 to 3, second, third, fourth, fifth, 1, 2, 3, 4, 5th, 6th, 7th, 8th, 9th, 10. After 10 switches, we will come to again the same process. So 10 into 5, 50. So 180 is the execution time of 9 process, 50 is the switching time. So it will be 230. 230. So option D is the correct option here. An organization has been assigned the IP address 205.211.9.0. So this is a class C IP address with subnet mask 255.255.255.240. What is the address of third host of the third subnet? So here based on the mask we can find out the IDs of subnets. So the mask is 255.255.255.240. So actually the default mask is 0.0. As we have the subnets for the main network, we have taken the mask as 240. So 240 means in a binary we can write like this 11110000. So here the subnet IDs, the first 4 bits we can use as a subnet ID, remaining 4 bits we can as a host ID actually. So these are the bits reserved because 11110000 it is equivalent to 240. So here the first subnet ID 0000, the second subnet ID 0001, the third one is 0010. But the third host 0000 we can't use as a host because that is a subnetwork address. The first host is 0001, 0010 is second host, 0011 is the third host. So the total 0010, 0011, it is the address of the third subnet and third host of the third subnet. This is equivalent to the value 35. So in this network, that is 205.211.9.35, this is the IP address of the third host of the third subnet. So which is option D. Option D is the correct option.